In April 2026, a factory in southern China ran a standardized safety check on a new battery pack. They took a steel nail and drove it straight through the center of a fully charged metallic cell. Usually, this results in a violent thermal runaway, but this time, nothing happened. No sparks, no smoke, no fire. That complete lack of a reaction is exactly what automotive engineers have spent years trying to achieve. It signals a quiet but permanent shift in the way electric vehicles are built. While companies like Tesla are still optimizing the same basic lithium-ion chemistry they've used for over a decade, China has begun mass-producing cells that completely eliminate flammable liquid electrolytes. The global battery war has entered a new phase. Right now, China is the only nation moving past the laboratory stage and shipping a next-generation product to the market. To see why this matters, we have to look at the architecture of every electric car on the road today.
They all rely on a flammable liquid electrolyte to move lithium ions back and forth between the electrodes. That liquid degrades over time, and it remains an inherent fire risk. It also creates a physical bottleneck. Because that liquid is volatile, there is a hard limit on how much energy can be safely packed into a cell, capping current density at about 200 to 300 watt-hours per kilogram. Solid-state batteries replace that liquid with a stable solid material, like ceramic or polymer. This shift allows manufacturers to use a lithium metal anode instead of graphite, which pushes the energy density up toward 500 watt-hours per kilogram. For the consumer, the impact is literal. In the exact same physical battery footprint, this chemistry allows an automaker to turn a 500-kilometer EV into a 1,000-kilometer EV. China's entire industrial base is currently mobilizing to scale this technology simultaneously. Greater Bay Technology recently concluded thermal shock and needle penetration tests on its solid-state cells, with no reported fires. They are now targeting gigawatt-hour scale mass production by 2026. CATL, the world's largest battery maker, is already expanding production of a 500 watt-hour per kilogram condensed battery while preparing a separate sulfide-based model for vehicle integration by 2027. The range claims are reaching unprecedented scales. Changan's Golden Bell buttons from Delhi to Mumbai without a single stop to plug in. To cement this lead, Beijing is preparing to release the first official national solid-state EV standard in July 2026. Literally writing the rules of the industry before the rest of the world has functional prototypes. Chinese manufacturers already control more than half the global battery market using older lithium-ion tech, and they are using that capital to accelerate the transition. This timeline chart illustrates the gap. While Chinese automakers target mass production by 2027, Japanese giants like Toyota and Honda are aiming for 2028, with mass manufacturing often pushed toward the end of the decade. The most significant Western contender is US-based Factorial Energy, which recently powered a test vehicle for over 1,200 kilometers. However, they remain several years away from achieving true manufacturing scale. In the battery industry, the winner is usually the one who achieves scale first. It takes years of iterative manufacturing to bring costs down, meaning China is locking in a decade of dominance while its rivals are still in development. This shift is a warning for emerging markets like India, where the booming EV sector is currently built on cheaper, range-limited lithium-ion chemistry. If solid-state costs drop aggressively by 2028, Chinese-derived battery technology will immediately undercut those vehicles, potentially mirroring the way Chinese solar panels reshaped that market years ago. The transition also changes which raw materials dictate geopolitical leverage. Solid-state reduces the reliance on cobalt-heavy cathodes, while increasing the demand for pure lithium metal and specialized ceramics. Global incentive schemes for battery manufacturing now face a choice: adapt to solid-state requirements immediately, or risk spending billions to build factories for technology that is already becoming outdated. However, the road to mass adoption is paved with physical friction. Ouyang Minggao, one of China's leading battery experts, predicts solid-state will capture only 1% of the market within the next decade. The manufacturing bottleneck is immense. Sulfide electrolytes are highly sensitive to moisture, making a 30-second factory cycle an entirely different physics problem than a controlled laboratory test. Most of the current production claims are still at the pilot scale. Transitioning from thousands of test cells to the millions of units required to move the global market is a multi-year hurdle. The honest read is that the market won't flip tomorrow.
But this is a race where China currently holds the most significant lead in battery technology, seen in 20 years. The question now is whether China has finally cracked the holy grail of automotive technology, or if manufacturing realities will delay these breakthroughs by another 2 years. I want to hear from the engineers and researchers in the audience. Will we see mass-market solid-state EVs by 2028, or is this still vaporware until 2030? Drop your prediction for the future in the comments below.